Okay, friends.
Sorry.
So let's make sure, because if you noticed, there was a forwards and backwards option, and then there was a between left and right option. I want to make sure we understand forwards and between before we get into forwards, left, and right, and then we'll wrap up with backwards, and I'll show you how we use all this stuff outside of the... There's no context right now. It's just showing you how to kind of push buttons on a program. There's not a whole lot of contextualness yet. So this was one standard deviation. So within one standard deviation, standard deviation is about 68% of the data. Let's do within 2 and 3. Now, again, you know the answers to these already. You know the answers to these because you learned them weeks ago. You know that there's 95% within 2, roughly, and there's roughly all of it within 3. But again, I want you to see the TI, the verbal program, and see how it runs through that and generate these values for you. And I want to also show you, again, I'm only doing these 3 because these are the 3 you already know. It can do lots and lots and lots more. So let's get into here.
Are you going to show us how to get it?
Yeah, let's go through it together.
I know the answer, but...
You do. It's 95%. So for a forwards problem, and again, you might ask yourself, okay, why is this forwards again? Well, I told you exactly, because we asked you to find the area or the percentage within 2 standard deviations. That number 2 means you're starting down here at -2 and going up here to +2, and essentially I'm asking you to find that area right there. That area right there. So it's a forwards problem. It's between.
How do you get to that area again really quick at the beginning to actually get to the
Program.
Oh, it's
It's the
program.
normal. Yeah, I don't know how to put these into your stat menu. So I had to put them in your program menu. I just don't know how to hardwire them into your stat menu. Left bound and right bound, -2 and 2. Cool. And here it comes. I'm going to draw it for you. Boop. There's your 95. Notice it's 95.45%. It's not exactly 95. I think the z-scores of -1.96 and 1.96 actually get you closer to exactly 95%. But who wants to remember those numbers? -2 and 2. 2 standard deviations, 95%. Gold. Fair enough? And then 3 standard deviations. Go ahead and run that one for practice. That would take us out to here. So essentially, you're picking up everything you've already picked up, plus a smidge more on both sides. And again, you probably remember this vaguely from before. I didn't hit 3 standard deviations very much. Back in the day. Because honestly, 2 is used more than 3. But we're going to go ahead and... Is everybody getting it to reload okay? When it says more prompts, you just keep hitting enter and it keeps going through. Between -3 and 3. And it looks like the entire graph is shaded. It's not. It's not. That graph goes on forever, as somebody pointed out earlier. I forget who it was. Somebody pointed out that it's infinite. It's asymptotic with the horizontal axis. And this guarantees why. You've only shaded 99.7% of the curve. Now, that's a lot. That's a lot of curve. But it's not all of it. There's still stuff in the tails that you haven't shaded yet. Let's make that a little bit brighter.
How do you change that? It seems like...
Say that again, Corey.
Oh no, how do I change, I'm just stuck on the 2 standard deviations.
Keep pressing enter. Sorry. Thank you, Corey. Keep pressing enter.
Yes,
I'm sorry. Guys, I apologize. I make this erroneous assumption. That everybody sitting in this class had me for Math 95.
Oh.
And in Math 95, all we do all day long is play with these things. And you get really comfortable with, this is called a pause. When I wrote this program, I put a pause into it. That's what that is right there. When you press enter, it jumps to the next screen. So every time you see a pause or a menu, you have to kind of just keep entering through it. Thank you, Corey, for bringing that up.
Yeah.
Cool?
So when I do -5 and 5, I'm getting 1.
Good. Thank you, Dave. Everybody, let's do 5 standard deviations. More, forward, between, -5 and 5. 5 standard deviations. So. Now, first of all, Athena says it looks just the same as 3 standard deviation. That's because the pixels you're seeing on this picture are essentially as refined as Pac-Man circa 1982. I mean, honestly, compare this to your phone. And there's no comparison, obviously. Right. What you're essentially seeing, Athena, is the previous one that was 3 stopped right here. And this one is stopping out here at -5. There is still space out there, so why is it see I saying 1? 1 makes it look like 100%.
You can't trust it.
Rounding.
Easy, Cedar.
It lies.
It's giving up and rounding to 4 decimals. It's rounding to 4 decimals, essentially, is what's going on. And it only holds, a computer can only be accurate to a certain number of decimal places, and then it has to round off. And what you've just found is that you found, I think if you go out to 4, it's 0.9999, and I think 5 is like the tip over, then it just calls it 100%. It gives up, essentially, is exactly right. Does that make sense, Dave?
Yep.
So it's not actually 1, it's 0.9 to a certain number of decimals. It's too much for it to carry, so it just calls it 100%. That does not mean that there's nothing outside of 5 standard deviations. It just means that it's so close to the 0 axis that we're calling it basically not there. Fair enough? But definitely trust it, Cedar. Please trust it. Please trust it. No, you don't. Okay. The main reason you want to trust it is because back in the day, and your textbook probably has this in it as well, there are tables of normal z-score values to the hundreds places that you used to have to use to calculate this stuff. This is so much better. This is so much better. It's more accurate. If you don't trust this, you would trust the tables even less, my friend. Guaranteed. Guaranteed. This is way, way more accurate. Okay, now, here's one you could also know the answer to without using your machines. Suppose I asked you, how much area is there between -2 and -1?
Didn't you make a change on that?
Well, what
You could, but you can also use geometry. I think it's easier, David. So, I'm running out of colors.
Not six?
Hang on.
I know that's not right.
I'm running out of colors. I'm going to try orange. Oh, there we go.
What do you figure you got 60-some%? You got
It's 1.
the next.
Listen over here. You can do some geometry.
So you got 68,
67 divided by
68,
4.
and then the next.
Hold that thought, Cassie. Please hold that thought, okay?
So
I think-
68 minus 95 divided by 2.
Okay, so check this out, friends.
Right.
What area is right here?
68%.
That's 68%.
95% minus 68%.
This is 95%. So if you take the middle 68 out,
And you leave the 2 outside there.
this has to be the difference of 95 and 68, which would be 27%.
Divided by 2.
Why divide by 2?
Because there's 2 zeros.
And because they are
Equal.
equal. So this from here to here would be 13.5%, wouldn't it?
Yep.
Double check it. Double check it. Double check it.
I concur.
Negative
I concur. I love the logic. So, yeah, forward between -2 and -1. It'll draw it for you.
Where have you go back?
Just keep pressing enter.
Enter.
Just keep pressing enter.
Fire.
Hot damn.
They're close.
Hot damn. And actually, see how it's a little bit more than 13.5? That's because we rounded off 95.4 to 95. So our estimate was a little bit low. Is that fair?
Totally.
Ish fair. Now, Cassie asked a fantastic question. She said, if this is 95% from here to here, why not just call each of these a quarter? Basically divide by 4.
Well, because
They're
it's.
not the same
Yeah,
height.
they're the same.
That's why. This is not what's called a uniform distribution. Remember uniform distributions from back in the day? And I say back then, I mean a week and a half ago. When you throw a die, for example, probability of every side is 1, 6, 1, 6, 1, 6, 1, 6. The graph looks like this.
Right, if it was a uniform distribution, it would be a straight line.
Exactly. It's a horizontal to rectangular
It's a
distribution.
rectangular shape.
This is hardly rectangular. So Cassie, you got it, my friend. You got it. But here's the beauty. Here's the beauty. You just have to make the connection that -2 to -1 is not the same as -1 to 0. Yes, it's the same distance, but that's not the same area above it. Is that fair?
Little squares have the same volume.
Say that again.
Little squares have the same volume.
You can- Exactly. You've got a different height, like you said, yes. Fair enough? Those are forwards betweens. But there are also forwards lefts and forwards rights. And you care about this. You care about this in context when you're trying to, for example, design doors or design safety margins on bridges. Or on your last take-home exam, I like to use there's a Northwest Airlines seat assignment that I like to use because I actually got some data from Northwest Airlines. I walked onto an air flight a while ago and I cracked my head on the ceiling. I'm like, holy crap, I had to duck walking down the aisle. And one of the stewardesses says, yeah, nobody above 5'7" can work on the flights. Because the ceilings are so low,
No way.
5'7" gave them the necessary like 2 inches of clearance. I think it was 5'9".
5'7"?
What's that?
You can't be above 5'7"?
On this plane, not in general, but on the plane that was flying from
Oh, the
Redmond to
one
wherever
in
I was
the front?
flying, you couldn't be above 5'7" because they needed to have at least 2 inches of OSHA clearance or something.
Weird.
And I was like, that's so cool. And then we pushed that as math, and they thought that was enjoyable. Because basically what you've done is you've blocked out 2/3 of people from working on that flight by doing that.
And you would
So-
assume that probably mostly, obviously, most people that want to be a steward would be female, the majority of them.
Anecdotally, I've seen that. I mean,
But-
I'd say one in
yeah.
5 are guys.
Yeah, but
Anecdotally.
I mean, more than likely, the women are gonna be shorter than.
On average, they are.
average.
On average, I think it's a 3-inch difference. And this is all, we're going to deal with all this in this class. I mean, this is one of the reasons I like ending with this in class. We deal with all these questions. So, cool? Makes sense? Now, so anyway, left and right problems. For example, same curve. And let's mix it up a little bit. Let's take it a little bit further than what our prior knowledge has. Let's say, because I like having -3, -2, 1. Those are great, but you can also go between these. Like, for example, you could start at -2.5 and go all the way down into the tail, always and forever, on and on and on, forever, never, never, never. How much area did I just shade right there? How much area did I just shade right there?
Let's see.
-2.5.
Now this is -2.5 off to infinity. So you could do it between, if you want to go between infinity and -2.5, but don't let me catch you doing that crap.
Oh.
Because you can't put infinity in as a number because it's not a number. But you don't have to. You don't have to. I've set the program up and I'll explain to you how it does it. I'll explain. What's
Going
that?
back to the infinity minus infinity.
Don't you start that, my guess. That's a dark period in my life I'm trying to forget about. We're going to go, it's still forwards.
Oh, we're gonna
It's still forwards because we still know the z-score is -2.5. I'm still looking for the areas up top. So it's still forwards.
Are we going left?
But now we're going to shade to the left. The area is shading to the left. And it asks for a right bound.
Right.
So it's -2.5. And it's going to draw it for you. Here it comes. It's hardly any area showing at all. But there it is. It's down there. It's down there. Here's -1, -2, -2.5 is right in here. It's right in here. And so it's going to shade that down. It's about 0.6%. Very, very little. 0.6%.
So just to make sure backwards, I know you don't want to think of it, but the way I think about it, because I've been trained by other math teachers and everything. So the inverse that you're talking about backwards, so basically it's just the below the x-axis?
No, don't think of it that way. That's the opposite, not backwards.
Okay.
Opposite mathematically means assign a negative number to it.
So
Take the
you're talking-
opposite up.
So you're talking about...
I'm talking about the idea of an inverse function.
Oh.
But I'm trying to avoid that word because I saw some twitches over here out of the periphery of my eye when I said the word. Yeah, it was right there.
So I'm assuming then what happens is...
Hold that thought, Rafa. Give me 5 minutes.
Okay.
We're good. I promise. I'm not ignoring because Jessica has the same question.
Because I
But
can't think of it.
we're all. This is all forwards right now. This is all forwards because you are starting with the z-scores down here, the numerical values, and you're getting the percentages off of those. That's why these are all. I call them forward problems, only because when I learned these first, so it seemed like okay, this is like the way we normally go. And honestly, sometimes it is. Sometimes it is. But the backwards ones are just as valuable. So everybody got the forward. You see what forwards is, ish. And we're going to see these more. It's not like we're not done with this, but I think everybody understands what a forwards problem is now. Now let's get a backwards problem. Okay. So that would look like this. Okay. Let's redraw the curve a little bit. Take him out. And take these away temporarily. I like leaving 0 in the middle. Because he's always got to be in the middle, at least for now. We're gonna replace him with something useful momentarily. But suppose 0 is in the middle, and I want to know how far out I've got to go in order to trap the top, I don't know,
I said what percent?
exactly, the top 20%. So I need, what percentile is that? There we go. Thank you, Charlie. It's the 80th, I haven't done that in a while, I promise. It's the 80th percentile, top 20, bottom 80th, right? So, this is what I call a backwards problem. Because you see, you have exactly the opposite of what you had before. Before you had a z and we're looking for a percent. Now you have a percent and you're looking for a z. Fair enough? Cool. All right, let's do it. More probs, yes. Backwards. Number 2. Area shades to the right. Which percent are we shading?
20?
0.2. Good. Absolutely. Make sure you put it as a decimal. I put that little reminder on there for you. Otherwise, he gets upset.
Yeah, I just took it.
Yeah.
I know, yeah, it gives you an error if you don't. There it is! The z-score is 0.84. Which means you've got to go roughly 0.84 of a standard deviation out to trap 20% here, 30% here between 0 and 0.84. Everybody see that? Why that's 30% right here?
Nope.
Half the curve. Half the curve is from 0 over.
Yep.
If 20's here, 30's here.
30's gotta be there.
Yeah, that's actually how I coded this. I actually coded this curve to use that fact. Because what Athena said is this thing goes out forever and forever infinity. You can't do that. You can't cap it at infinity. So what I did was I did 0.5 minus this gives me this and use that and work with a finite amount. So I had to use that fact when I was writing this program for you guys, which was actually kind of fun. And I would use it with the 89 too if I could get my hands on one.
Well,
Fair?
I'll give you mine.
Well,
Let you work with it.
I know, I need to
I
take it.
will.
I need to take it and just have it
Yeah.
and program it. Now, there are backwards problems that are a little bit, I don't know, like for example, here's a backwards problem for you. Find Q1.
Quadrant?
What's Q1? Q sub 1? Think of your last exam. The 25th percentile. Exactly, Cassie. Sorry, I forgot to write. I said one, I forgot to write it. The first quartile is the same as the 25th percentile. Find it for me, friends. Find me the 25th percentile. Which z-score is the 25th percentile? Now you can envision where it is.
Yeah.
You can envision where it is roughly, but I want to know the 2 decimal places where it is. So you can envision, it's not over here for sure. 25th percentile, right? First quartile, 25th percentile. So, tell you what. I'm going to move the marker from left to right. You tell me where to stop, where you think it's going to be.
Yeah.
What? There.
There, boom.
Negative
0.67.
I concur.
That's what 25th percentile is. It's the z-score that chops off the bottom 25%, or the top 75, however you want to look at it. But by definition, a percentile, the bottom 25%. Fair-ish? I mean, all I'm doing is going back to the definition of a quartile. It's the 25th percentile. Let's find it. Yeah, I know you did. It's a backwards problem. We're shading left this time.
It's really awesome fancy dandy, like, program.
It's pretty awesome.
I don't have to use my brain.
No, you do. We're automating this part of it, but the question I'm about to ask you is going to force you to use your brain to transfer to this. This is the part what I don't want to test you on is rote memorization of facts. That's what this is doing for you. There you go. Negative 0.67. That's your z-score. 2/3 of a standard deviation down, right? Negative 0.67. 2/3 of a standard deviation down. So, without using your TI, I love what I hear makes sense. It makes me happy. Give me the 3rd quartile. Knowing that negative 0.67 is the first quartile, give me the 3rd. 0.67. Has to be the positive version, doesn't it? Right? It has to be. It has to be. Because if this is 25% right here, there's symmetry involved, correct? This curve is symmetric, which means if I come over here at positive 0.67, this area here is 25% as well, which means between these two is 50.
Right.
50 plus 25 75. Which is actually, I find this very, very cool because we memorize 1, 2, and 3 standard deviations. Within 1 standard deviation is 68%, within 2 is 95, within 3. I love this. Within 2/3 of a standard deviation is half of your data. I love that. That to me is more interesting. Half of your data, 50%, is between negative 0.67 and positive 0.67. Within 2/3 of a standard deviation. You don't share my enthusiasm, that's okay. Yes, Kelsey.
So this is assuming all your data has a middle point of 0, though.
And a standard deviation of 1.
So
Kelsey, thank you. Thank you. How many of you, the perfect segue, I couldn't ask for a better one.
What did she say though?
She said, the most important, and this actually ties into what Athena was just saying too. She said, this assumes that your data has a middle of 0, an average of 0, and a standard deviation of 1. What if it doesn't? That's a fantastic question. I'm going to ask a question. No, it's okay. We have a quick fix for it, Corey. Of course. How many of you have ever called somebody a moron?
Ooh.
Never.
Do you want us to say how many times?
Imbecile. Feeble-minded. I just learned this one today.
Yeah, I probably did.
Why have you done that?
Because I got pissed off.
Because you got pissed off. That's a good answer.
Because they were.
Because they were. So these are all derogatory terms.
Maybe I overreacted. I don't
Do you know where they come from? Those words.
Learned.
Learn from what? This is a fantastic story.
Things I've watched, TV, people I've seen say that.
Before that even.
Old English.
Not quite that old.
Yeah, I'm not that old.
1950s, 60s IQ levels.
Oh, yeah.
Those used to be IQ levels. For example, if you scored an IQ between, I think it was 50, hang on a second, I gotta get this right. It's either, I think it's 0 to 25, you were considered, I believe, an idiot. 25 to 50, you were considered an imbecile. 50 to 70 or something, you were a moron, and so forth and so on. Feeble-minded was somewhere in there. Then there was normal. Then there was genius and all these other kinds of labels. But that's where those words came from. They were actually serious terms. Like moron, and people made claims like, if a moron and an idiot have children, there's a 75% chance their children's going to be feeble-minded. I mean, literally. I swear to God, you laugh. This was serious research 50 years ago.
Yeah, they had some interesting theories.
These were serious. So, I have a question for you. Here's my question I have for you.
How many of us?
Hang on a second. I gotta get a better
How many
fact
of
up.
us are feeble-minded?
No, I don't give a crap about that.
Joel normal.
The IQ ratings have been PC adjusted.
Okay.
We no longer say things like idiot. We now say things like dull normal. So, the question I have for you, what percent of adults are dull normal? Which means they have an IQ between 80 and 90. Kelsey, this comes directly out of the question you just asked me. Because what can you do with your technology, but it won't be the right thing to do right now? What? Time out. Better question. Is this a forwards problem or a backwards problem?
Backwards. Forward.
I love dissension. I heard both.
I
What
don't
are these
know.
forwards?
Is it forwards or backwards? Kathy, you're pretty strongly voting for forwards. Gotta tell me why.
Just because I feel like your 80 and 90 would be on the bottom, and then you're looking for higher, you know?
She's 100% correct. Because look at the question, the first two words. What percent?
You
I
mean
want to
that-
know what the percentage is, which means that I know the percentage, which means I'm looking for the top, and Kathy, you're correct. 80 and 90 are on the bottom. Thank you. Now here's the problem. Here's the problem. Let's come over here. So, here is the IQ curve.
They've actually disproved the whole IQ test, by the way.
Well,
Yeah, those are questions they have on
hang on, friends. I'm not interested in the implications of IQ because honestly, nobody knows what the hell it means. I can't even define it.
Yeah, they don't know what it is.
I just reread on this trip I was just on recently the beginning of Hitchhiker's Guide to the Galaxy, where I was awesomely reminded that the most intelligent creatures on Earth are not humans or dolphins, but little white mice. That's such a great play on the idea of intelligence. Just putting that in there, just rubbing it in our face that we don't know what intelligence even means. However, I do guarantee you that I can tell you what the average on an IQ test is. Do you know what the average on an IQ test is? Always, by definition, it's 100. Do you know why? Kelsey, this is answering your question for you, in one way, with one example.
It's right in the middle.
Why? Why is it right in the middle? Yes, it is.
Because you
It
get
is.
0, which is the lowest.
Oh, you know what I should
You
do?
have 100, which is your center, and I'm assuming that the highest score could only be a 200.
No. Actually, there technically is no highest
No,
score.
that's the average score of the population, I would
There is technically no highest score. Why is it? What does IQ stand for? Intelligence quotient.
So that's the
What does quotient mean?
average of the population.
What does quotient mean from arithmetic?
Division?
Division. What are you dividing to get these value? To get this value? You may have never learned this before. It's okay. You take your mental age and divide it by your chronological age. That's what an IQ is. So, for example, if a 4-year-old child takes an IQ test and tests like a 5-year-old child, that kid has an IQ of 120 because 5 divided by 4 is 1.2. Oh, it's still 125. 5 divided by 4 is 1.25 times 100 is 125. That puts him over on this side of the curve. This is actually 100, not 0. However, if you test mentally exactly the same as you are chronologically, Your age divided by your age is 1 times 100 is 100. That's why 100's in the middle. It has to be in the middle because they set the test up that way. I'm not, and again, Raphael, this is the difference between what you're saying and what I'm saying. I'm not worried about what it implies. I'm just saying that has to be how it is because they made it be that way.
Right.
Is that fair?
Yeah, absolutely.
Awesome.
Yeah.
Now here's the problem, friends, and this goes back to Kelsey's question. That's the IQ curve. How about the normal curve? Well, it's over here. It's over here with 0 in the middle. Your entire program is based on this curve. All right? We want to know what percent of adults are dull normal, 80 and 90. Well, here.
So,
90's here, right? 80's here. I want to know that. Because that will answer this question. And the thing is, you have to know, IQ is bell-shaped. Again, it has to be because it's been set up that way.
Is that the 13.7 or is that?
Good. Very good question. Very good question. Remember that
Or no,
13?
it's not, it's set up differently.
Hang on. This is great, Cassie. Remember what she said? Earlier, we discovered that between -2 and -1 was about 13.5% of the data, right? But, Tabitha, go ahead.